First thing I really need, though, is a volunteer. Attaboy. It's going to be different today. We've got a cart here. Got a rope attached to the cart. Okay, I'm going to sit on the cart this time, so you can pull me around. Right. Pull me to the other side of the room. I like this idea. Don't crash me. All right. Let's go back again. Feel how hard that was? Not very hard, was it? Because I'm a little guy. What if I get off it? Now pull the cart. Easier or harder? Okay? Remember that. Bring it back here. Now, you got to attach to a rope there, right? Get my feet up. Shorten the rope. Shorter. Shorter. Not that short. Not that short. Let's make it this long.
This long?
Okay?
Okay.
Pull on the rope. Easier or harder? Okay? How could you make it easiest as possible to pull on that rope? Okay, and what does that do? No, not in this case. It'd be nice if it did, because it really magnifies. What does it do to my rope? The longer it is, what does it do? Short rope, long rope. Short rope changes the angle. The longer the rope, the shorter the angle, the smaller the angle is. Lean down and pull. Is it easier or harder? It's a lot easier. And we'll see why. Next. I've been going easy on him. Pull me. Easier or harder? Why? Well, what difference does that make? Oh, friction. Yeah, that's right. We got to talk about friction today. We are bringing friction into our problems. We ignored it so far. Now what I want you to do is I want you to pull on it and tell me what happens once I start moving. Let's try it again. Okay, let's try it again. I want to just think about just as I start to move. So you start pulling. Is it easier to get me started or to keep me going? Okay. There. Enough of that. Friction. What is friction? Oops. Friction is a force that opposes motion. It always opposes motion. Is friction good or bad in a car? Good. Why? If you don't have friction, could you ever stop? No, because what do brakes do? Provide friction. If there were no friction, would you ever start? No, because if there's no friction between your tires and the road, they would just spin, right? It'd be like being on ice. What if you did get going and you tried to turn a corner? Well, you wouldn't necessarily die. But you keep going straight. Why? Newton's first law of motion. You continue in a straight line unless acted upon by an external force. What is the external force that allows you to turn a corner? Friction. Think about living around here in the wintertime. You're driving along the road and all of a sudden you hit an icy patch. What does your car want to do? Go in a straight line. Unfortunately, the road curves sometimes. And you end up in the ditch. So friction is a good thing. Here's something else we haven't talked about for cars that applies to Newton's law of motion. How many of you wear a seatbelt? Good. Why? Other than the law tells you to. What is the function of a seatbelt? Which means what does it do? How does it, not friction. Friction is not the right answer this time. It has to do with inertia. Okay, if you're in straight line, uniform straight line motion, you will continue so unless acted upon by an external force, right? So you're in a car, and the car suddenly stops. You would keep going until you act upon it by an external force. Where is that external force going to be? Steering wheel, the windshield, the road in front of you, unless you're wearing a seatbelt. What does the seatbelt actually do? It supplies that external force, but it makes you a part of the car. Since you're strapped in there, if the car stops, you stop. And don't keep going. And that's what can be hazardous in car accidents. That's why so many more people survive with seatbelts on, because they become part of the car. And where's all the force being exerted on your body? Right here across your chest, across your lap. If you're not part of the car, no seatbelt on, where is probably the force going to be exerted on your body? Your melon. A lot easier damaged and a lot more dangerous to damage. All right, friction comes in two types, kinetic and static. What does kinetic mean? What does static mean? Static means not moving. Kinetic means moving. When Dylan pulled on me, as I'm sitting there, he has to overcome what's called static friction. And then once I get moving, he has to overcome kinetic friction. Now, is friction always the same? What does it depend on? Depends on the two surfaces in contact. How much of the surfaces are in contact? What are those two surfaces like? You know, your tires in contact with pavement have a different amount of friction than your tires in contact with ice or with concrete even. But kinetic is moving, static is not moving. Kinetic friction is always less than static friction. It's always easier to keep something moving than to get it moving. Kinetic is always less than static. Now, how do we actually measure friction? Well, the amount of friction also depends on one other thing. What was that one other thing that it depended upon? Compared empty with me on it. Okay, mass isn't exactly it. In this case, it actually is weight. Because if we went to the moon, would it be easier to pull me there? Yeah. I would have the same amount of mass, I'd have different amount of weight. Now what it actually depends on the force of friction. Here's a formula for you. Oh, yeah, we can do that. There's the formula. Force of friction is mu times the normal force. Mu is a Greek letter. It looks like a U, except it's got a tail on both ends. It stands for the coefficient of friction. The coefficient of friction is how sticky the two surfaces are to each other. And all, different surfaces have different coefficients. They range from near 0, which is frictionless, to 1, maybe a little more. So force of friction is the coefficient times the normal force. Now, in the case of being on this cart, what is the normal force as I stand on it? No. If the normal force were 0, I would fall through the floor. just vote and shh. You can only do one thing at a time, obviously. What is a normal force? What's pushing? How much force is pushing back up on me? As much as I weigh. Okay. Which is why if we went to the moon, there'd be less friction because the normal force would be less. The normal force is equal to the opposite to the weight. Now, when isn't the normal force equal to my weight? We'll see that in a little bit. All right, some examples.